Question 8. Eugene conducts an experiment to confirm the melting point of naphthalene. He first heats up the naphthalene to 140 degrees Celsius. Then he places the hot liquid naphthalene out to cool in the surroundings. So over here, I can identify that my original state of naphthalene is liquid, and this naphthalene is placed out to cool in the surroundings. So figure 8.1 shows the cooling curve of naphthalene in the surroundings. So state the process which naphthalene is going through from time t equals to 3 minutes to 7 minutes. So since it is in liquid state, the next time which it will undergo a change of state without a change in temperature would be when naphthalene turns from liquid to solid. So at this point of the graph, we can see that at temperature equals to 80 degrees, naphthalene is going through freezing, whereby it's turning from liquid into solid state. You can also call this process solidification. Question 8, part B. Explain why there is no change in temperature after naphthalene reaches 20 degrees Celsius. So if we look at this part of the graph over here, even though at 80 degrees here, it has already turned into solid, the temperature continues to cool all the way until this point over here, which remains constant after that. So the reason why is because at time equals to 12 minutes at 20 degrees Celsius, naphthalene reaches thermal equilibrium, which happens when the temperature of naphthalene is equal to the temperature of the surroundings. So simply, the reason why there is no change in temperature is because naphthalene has reached thermal equilibrium with the surroundings. Or you can also say that there is no transfer of energy between naphthalene and the surroundings. Okay, moving on to question 8, part C. Explain why the internal energy of naphthalene decreases from time equals to 3 minutes to 7 minutes. So as we have identified in part A, during this time interval, naphthalene is undergoing freezing. So during freezing, molecules become more packed, and the relative separation between particles decreases. So this is a fact that we know about freezing. The separation between particles decreases. So since we know that internal energy is made out of two things, internal potential energy and internal kinetic energy, and at constant temperature, internal kinetic energy has no change. So therefore, in terms of internal potential energy, since the relative separation of particles decrease, this directly affects the internal potential energy. So hence, internal potential energy decreases, and this leads to internal energy decreasing. So this will be 2 marking points for this question, stating that the relative separation between particles decreases earns you one mark, and then identifying that internal potential energy decreases will give you the other mark for this question. So this will be all for question 8.